team, another team, which the customer is an industrial customer, a friend of Boston University. Technofrolics has sponsored numerous projects in the past, and again, they have sponsored a project again this year. Again, we really appreciate external customers who are providing our seniors with real-world problems that will help them in their own businesses. This team, Team 4, is Team Illuminati, and we may begin.
All right, good afternoon, everyone. We're Team Illuminati, and this is a presentation on our project, LED Controller System. In the beginning of the school year, we were given the task by Technofrolics, our customer, to design a product in the field of showcase design that can be used by customers who are looking to present themselves in a unique, different way at events such as trade shows. Team Illuminati's goal was to create a highly scalable system that would essentially incorporate an array of modules, each of which contains a matrix of LEDs, where the customer could buy as many units as they wished, depending on their application. The product was meant to be comparable to higher-end systems in terms of functionality, and yet be cost efficient in the market. Some competing technologies on the high-end side, there's the cost could go anywhere from $1,000 to $100,000. And an example of this is the Philips Color Kinetics system, which can be seen here. On the low-end side, you can go with simple Christmas decorations, Christmas lights, which, although cheap, are very ineffectual in their design. Just to give you a quick overview of the technical requirements, of the core technical requirements. First and foremost, the controller must be wirelessly programmable from a Windows PC. There shouldn't be any wires at all, meaning that it should be powered by a battery pack, and you should be able to communicate to each of the modules from a PC. There should be 16 RGB LEDs per controller unit. The controller must be compatible with off-board LEDs, which means that the customer should be able to physically modify the design, which he or she has programmed onto the device. The software must be scalable to 16 modules, 16 controller units, and each LED module must be able to operate at any color simultaneously and independently of other LEDs.
So here we have an overall block diagram of the hardware. As you can see, we sought to power this thing with AA batteries. We needed 4 AA batteries to get any sort of longevity out of these. Since we're driving a bunch of LEDs, they actually do consume a significant amount of current. Batteries are run through a voltage regulator, which will smooth the voltage out to 3.3 volts, which all of our logic systems use, all of our digital systems. The core of our design is an SP430. We went with one of Texas Instruments' more powerful ones that they just came out with. I believe the clock speed's up to 25 megahertz. For wireless communication, we decided to go with Wi-Fi instead of Zigbee due to increased range and just the prevalence of having Wi-Fi networks in any of these locations when we set up these products. We went with the RN131 Wi-Fi chip. For data storage, we're using an SD card. And to actually drive the LEDs, we're using common anode current drivers. By using current drivers, we're able to protect the LEDs by not putting too much current over them, and that way we don't have to worry about burning them out. And also, the intensity of an LED is more accurately based on the current going through it instead of the voltage applied to the eye. So this way we're able to produce more regular results. So the significant portion of our hardware project was designing a PCB. That's just the one PCB, nothing on it. As you can see here, the 80-pin MSP package really is the core of our system. It's located in the middle. Current drivers all extend down here.
So designing the software for this project was a little interesting because it required for us to be able to output a constant, stable 30 frames a second of visuals. And considering that we have, as you just saw, a very distributed system where we have multiple buses with data coming in and out, we have Wi-Fi coming in over UART, we have to fetch choreography instructions from SD over SPI, and as well as then the data going back out to the current channels over I2C. We had a lot, there's a lot of different calls going on as each frame is calculated. So we had to do this in a way such that everything could be done at a fast enough so that we wouldn't start experiencing lag. All right, so this is my MS Paint rendering of what our software is sort of designed after. We opted to go with a limited subset of C++ rather than the more mainstream C when programming our MSP. But as Professor Durano said, this product will eventually, hopefully, go to market. So we had to design something in a stable enough way, and also something that can then be picked up by an engineer who's not familiar with the code, read it, understand how it operates, and then build upon it so that eventually it can become robust enough and stable enough for market. So we designed some LED objects which can then call the instruction manager, telling it, oh, like I need this instruction, and then it can then abstract the SD card, go fetch the instruction that it needs, pull it back in. Then when our interrupt timer fires, which tells it, all right, we need to start producing the next frame, it flushes those values out to the I2C buffers, which then go out to the actual current drivers, and then begins to pre-populate the data necessary for the next frame coming up, which might include just actually having to go out and fetch a different sector from the SD card, and then also using other interrupts, constantly listening over UART to see if the Wi-Fi is giving us a different instruction to run a different program instead.
Right, yeah, so our ECE software is just a simple user interface where they can select a CSV file, which is just a text file with the various parameters controlling the LED behavior, separated by commas, and it reads it in. You can see any modules that are currently connecting to your program through just a standard TCP/IP socket connection. And then you can load it onto the selected module, and it will tell you when it's done loading. And then you can click start or stop and control when the LED sequence begins synchronizing, essentially.
For future development, we're going to where you can possibly fix the PCB errors that we had. The JPEG header was misconnected, and the SD card traces had some faulty tracing, so we fixed them on the boards. But for future development, it should be fixed on the PCB design. The SD power transistor and some pins have to be left in the MSP and the PS. Also, integrated CSV creation tool, which make it easier for the user to create the patterns that they would like to show on the LEDs, and implement FAT32 on the SD card and improve wireless. We're delivering 3 fabricated PCB boards, complete wireless programmability, a battery compatibility, and over 30 offboard LEDs, and user documentation and project logs for any additional data or development.
Can you describe the working display as you conceive it?
You wanna come see it?
Well,
Describe it in
I mean,
terms of-
is it just LEDs hanging on wires, or?
Yeah, so for now it's LEDs on wires. Ideally, you'll then be able to attach that to a 3D model
So does each board have 30 off-board LEDs?
16.
Yeah, each board has 16 connectors, which you can, or you don't have to connect an LED onto. And then the SD card stores your choreography data set, and then when it starts reading, it changes each LED output at each frame.
So my choreography is a time history of each of the 16 lines being on or off?
Right, so we
Nice.
actually,
History.
just for robustness, we created an instruction set which allows us to, rather than have to every single frame read a new instruction, we created an instruction system that would say, all right, fade from this color to this color linearly over 1 second, or stroke at this rate, at this color, for this many seconds, or there's a few other more advanced transitions which we came up with. If that answers your question. Yes.
I think I might have missed this. When you say big wireless programmability, you mean using like your computer systems, you can program your instruction set? Like
Right, so just to, a big part of this for us was power, so that we were constantly streaming data over Wi-Fi, we'd be sucking up power, so we like to preload the SD card. So when we take that CSV file and open it in our PC software, we click send, it opens a TCP stream, which allows us to then dump the entire set of choreography onto the SD card ahead of time.
Okay, and now can you do that? You said you're supposed to be able to support like 16 modules, I guess?
Yep.
Using that same.
Different, 16 modules with 16 LEDs each.
Okay, is there a method that you have to specify which one you're dumping on, I guess?
Yeah, you select, in the GUI, you just select one of the LED modules from the list. Can't see it.
Right, no, I mean like, you said you have, okay, sure.
Yeah, so you can, there'll be a list here, which we actually should use a screenshot that has the modules in there. Each module is named separately, and you can click on that. There's jumpers which you can set on the PCB, which provide a unique ID, so that when it shows up on here, you can see, oh, like, we need to put this choreography set on this one, and then it will stream to the card after.
So why was the input to your system chosen to be an SV file, or was that a customer?
So, it's our understanding that there's very elaborate theater software out there for choreographing lighting displays, and whereas it's very tedious to just enter CSV manually, which is why you'll see our demo is not the most incredible display, but you'll eventually be able to integrate this choreography software, which is able to output in CSV format. So you can create, it's almost like if anyone's ever done movie editing, like Premiere or whatever, you can do that and then you hit export and it will just dump it all into a CSV or something along those lines, which then you can then import onto the device, allow you to create some pretty complex displays.
One other question, you indicated the maximum number of modules is 16, what limits the number of modules?
It doesn't.
Yeah, it's pretty much just how much can your network handle at any given moment. Obviously, if you're throwing around too many Wi-Fi signals, you'll start interfering with each other.
Your time would really build up during the preloading, but for as far as start goes, implemented correctly, it's a UDP multi-casted star signal. So, if something's on that network in your subnet listening on that port, you can trigger hundreds, I suppose, if you want, of
Right now,
modules to start it.
the only limitation on the hardware is we only put 4 jumpers, so there's only a 4-bit address on the hardware. But you could just add more jumpers to make longer address lines.
Or another, if you also saw on our future